Hi everyone. Today we'll take a look at radical functions. So a radical function is when we have something under a square root, right? So square root, and then we denote whatever's underneath the square root as f of x, right? So let's understand the general properties of this function, all right? So the first thing that we need to know, is that we need to know the domain and the range of how this function unfolds, right? So, well, evidently we can see that it's under a square root. So we know that square root must be greater than or equal to 0. Therefore, we can say that the domain is basically when f of x is greater than or equal to 0, right? We also know that the range will also be, y is greater than or equal to 0, right? The lowest possible value that the domain we can have is the domain as 0. Inside the square root, 0 is the lowest value that can be accepted, right? And if that's the lowest value that can be accepted, the lowest value that can be, given out as output or range will be 0, right? So now let me just draw, a general curve of a very basic function, which I'm going to do is y is equal to square root of x, right? So I'm going to take in this example as y is equal to square root of x. Very basic, nothing too crazy, right? So now it's going to be like this. These are my axes, right? So these are my axes, right? So y and then x right here, right? So what I'm going to do is I'm just going to, okay, I'm going to keep it as it is right now, right? And I'm going to take it in line, right? So this function, right, the general shape is going to be something like this. Something like this. It's going to continue, right? It's not going to, there's no horizontal asymptote like we had in rational functions, right? It's going to go on forever and ever, right? It's going to increase steadily. It will increase steadily and steadily like this, or as x increases, right? So y will increase as x increases, but it'll slowly, it'll be slow in the beginning, and then it'll be rapid, right? It'll be slightly rapid, or it won't really be rapid. It actually decrease as it goes in the future. It'll slow down. But if you want, you can think of this as like a sideways parabola, right? Maybe if you had like this, and then if you were to rotate the entire thing, it would look like a parabola. So yeah, it's kind of like a sideways parabola because it is like the inverse of a parabola, right? I won't get too much into it right now, but if you know what I'm talking about, that's great. If you don't, it's also fine, right? So here, now in this example, right? In this example, the domain is basically x should be greater than 0, right? Because f of x here, in this case, f of x is equal to x, right? Where x is greater than 0, therefore y is also greater than 0, right? That is like the general form, right? Now let me just show you. Let's discuss a a variation, right? Let's discuss a variation that would occur. So what if we had y is equal to square root of negative x, right? Nothing would here be different here, right? So we can say that negative x must be greater than 0, right? So that means x must be less than 0. That's our domain, right? This is our domain. Similarly, range is basically, if this is going to yield in all positive values inside the square root, we're still going to have y is going to be greater than 0 for all of them, right? So y will be greater than 0, right? So our graph will be something like this, like this. It's gonna be like it's gonna be a reflection across the y axis. It's gonna be a reflection across the y axis. You can think of it like that. So now again, let's take one more variation as an example, right? So if I were to take y is equal to negative square root of x, right? So again, domain would be x is greater than 0, right? Here, y, so this area would yield in all positive values. But because there's a negative sign, all the positive would become negative. So y would be less than 0. So our function would come out something like this, like this. So I just wanted to show you the different variations that can occur. Now again, if you take, if you, let me change the color one more time. And maybe if you were to take y is equal to negative of square root of negative x, like this, right? If you took this, then you would have this line right here, like this, right? all branching out from the origin, right? All branching from the origin, you're going to have something like this. So here, the domain would be x is less than 0 and y is less than 0, right? Something like that. It's really straightforward. You just have to work with the concept, right? If you deviate from the basic understanding of how a radical function is supposed to work, right, you will mess up your domain and range. And majority of the questions are just gonna say, okay, find the domain and the range of this radical function, right? I doubt they'll ever ask you to graph it because it can get really hairy at times. Just have to be careful of that. And honestly, you're good to go. You don't have to worry about anything else. So let's look at a few example questions and let's try to get a better understanding of it. We won't do a lot. We'll do a few because this isn't a very it's not a very prominent topic in functions at all. All right. So in this question, we're supposed to find the domain and range of the function y is equal to square root of x minus 2. Right, so let's start the basic things, right? So we know that everything inside the square root should be positive, right? So the only way we can get everything to be positive is when we say that it's going to be supposed to be greater than or equal to 0, right? So if we do that, we get x is greater than or equal to 2, right? So this is our final, domain, right? That's going to be our domain. Our range, there's nothing outside the square root. So everything inside the square root must be greater than or equal to 0. Thus, everything, the output, right? The output the square root will yield will be, y will be greater than or equal to 0, right? So that's going to be our range, right? Greater than or equal to 0, right? So now if you want to plot this, right? So we can, right? Even though the question hasn't asked us, we can still plot this, right? So if I were to, draw the axes right here, this, and like this, right? So here's my x, here is my y. If I want to, I could draw it really easily. So I know that y will be 0 when x is equal to 2, right? I know that, right? That is the lowest possible, value of x I can take and the lowest possible value of y I can take, right? So I'll change the color. I'll take yellow again. So if I think this is 1, this is 2, it's going to be somewhere here, right? And then it's going to follow my general curve of my radical function, right? It's going to increase like this, slowly. It's going to increase like this. So again, I've drawn the general curve and I found the domain and range quite successfully. All right, so here we have to find the domain and range of y is equal to 1 plus square root of 2 minus 4x, right? So let's start with the domain, right? Okay, so let's break this up, right? We'll break this up into two different sections. We have this and this, right? So the domain of this doesn't really exist, right? This is just a 1. You're just adding 1 to whatever is happening inside here, right? So we can basically ignore this, right? So this won't contribute, anything. This won't affect the domain in any means, right? So let's just focus on this part that I've underlined in purple, right? So we have everything under the square root, right? That's what matters. 2 minus 4x. Now, again, we know that this cannot be negative, right? So it has to be greater than or equal to 0. Right? So if I solve for this, I get 2 is greater than or equal to 4x. I divide by 4 on both sides, right? So I'm going to get x is less than or equal to 1/2, right? That is my domain, right? All values less than or equal to half will satisfy this function, right? That's all that I have to worry about in this function. So let me rewrite this here. Okay, so yeah, that is my domain, right? Domain. And my range, right? My range won't be this. No, it won't be this. It won't be greater than or equal to 0 because we have a plus 1 here. Now this is where the range is going to be affected by the 1. So we know that the lowest possible value that this can take is half. So the greatest possible value can take is half, right? Doesn't matter. It's still going to yield. It will still yield a 0, right? This can still be 0, but the entire y value won't be 0. It's going to be 1 plus 0, right? So the lowest possible value is 0, but we're also adding a 1. So it's actually going to be y is equal to 1. That is going to be the lowest possible value. So it's going to be y is equal to 1 and all the numbers greater than 1, right? So my range becomes y is greater than or equal to 1, right? That becomes my range. right? So this becomes my range, right? It's not 0, it's 1 because we're adding a 1, right? Maybe if it was, if it was instead of adding 1, it was maybe subtracting 1, right? If this didn't exist and if it was -1, then our range would have been y is greater than or equal to -1, right? We can still have that as long as we know, as long as we don't mess up with the domain and we don't create a negative value inside the square root, we're okay, right? It doesn't matter. So we can still have the output as a negative. It just doesn't matter. We just have to be careful with what we define as the domain, right? So let me just undo this. All right, cool. So again, they haven't asked us to plot it, but if we had to plot it again, it wouldn't make much of a difference. So um, it would be something like here, like this, and I'm going to draw it like this. So this time our graph is actually going to come in the second quadrant. Now, it's okay if you didn't realize it, that's fine. I realized it because it's a negative x, negative something coefficient and then x. If it was a positive, it would come in the first quadrant, right? But this time it's going to come in the second quadrant because y is obviously positive, but we're going to take majority negative values of x's, right? It's going to be half, 0, -1, -10. All of those values are going to be taken, right? So the lowest, my starting point is going to be half comma 1, right? So it's going to be, if this is 1, right? So my half is going to be here, my 1 is going to be here, right? So this is 1, 1. So half comma 1 would be right here, right? And then from here, my function would go like this, something like this, right? Essentially this would be my function, right? Of y is equal to 1 plus 2 minus 4, square root of 2 minus 4x. Let's look at, a few more examples. All right, let's find the domain and range of this function. Okay. So again, let's break this up, right? We have this and this, right? So again, the 3 won't really affect the domain in any way. So I'm going to ignore that, right? Because it's all dependent on x, right? So we just have to focus on the square root. So we just have to make sure the square root is positive every single time, right? So to make it positive, we just have to make sure that whatever inside the square root is positive, right? So 2x plus 1 must be greater than or equal to 0 at all costs. If that is the case, this needs to be, on the other side, x will be greater than or equal to negative half, right? So negative half. That's my domain, right? Domain. Now, what's going to be my range? That's going to be the tricky part here, right? So, okay. So now I have found the smallest possible value. The smallest possible value that can be taken is 0, right? So 3 minus 0 is 3, right? That is like, I can start with that, right? Let's start with that. Now I know this is going to increase and increase, right? So this will increase and increase as x increases, right? That's pretty obvious as well. So if I have 100, it's going to be 200 plus 1, which is square root of 201. I don't even know what that is. Probably around 14, a little bit less than 15, a little bit, I think around 14, 15, right? So it's going to be like 3 minus 14, which is going to be like negative 11. So as you can see, as x increases, whatever is in the square root also increases. But because it's negative, 3 minus that is going to result in values less than 3. So as x increases, y will decrease. Y will decrease every time. So the greatest possible value that we can start with is 3. Everything else will be less than 3 every time, right? Suppose I take x is equal to 4, right? When x is equal to 4, right, we have, so 2 times 4 plus 1, which is 9, right? So 3 minus square root of 9, which is also 3. So 3 minus 3 is 0, right? So for x equal to 4, y is equal to 0. So you can see as x increases, y is decreasing because there's a negative sign there. So the greatest possible value that we can have is y is equal to 3 when this entire square root is equal to 0. So based on that observation, right? This is completely observation. There is no mechanical work here. Every time the question changes, you're going to have a different scenario. You're going to have to work differently, and then you're going to have to determine the domain and the range. That's why it can get a little tricky. But if you follow these steps, right? If you work logically, right? There is no mechanical work. There is no formula here, right? It's just simple logic when you have to find domain and range for every single function, whether it's radical, whether it's rational, whether it's going to be absolute, which we're going to discuss in the next video, right? Every time, whether we have composite functions as well, right? When we have composite, we're going to have f into g of x, right? We'll take a look at that later on, right? When we have trigonometry, right? Maybe when we have, something like sine of 1 upon x, right? All of these things, they all have to be done logically because every time the approach is going to be different, right? The general steps are the same. You have to look for the odd ones out, right? Would create the differences, right? But every time there will be a different case. So you have to work with a concept in mind. You have to understand what the function is doing. All right, so based on that, right? So my range will be y is less than or equal to 3, right? That is the greatest possible value that can be taken. And so that is going to be my range, right? Let's look at one last example. All right, so in this question, I haven't really written find the domain in range, but you get the gist of it, right? So again, let's start. So we have to find the domain and range of this function, right? Again, we can ignore this, we can ignore even this, right? What we need to focus on is everything inside the square because that is the only constraint in the entire function. Right, so let's focus on this. We have to make sure this is positive, quite simple, right? All we have to do is make sure that it is greater than or equal to 0. And we can say this. So our domain, right? Our domain is like this. So x is less than or equal to 2, right? Like this. Now, my range, again, so the lowest possible value that can be taken is 0. So if we have 0, we're going to have something like y is equal to 1 minus 3 times 0. So this will be cancelled, so it's going to be 1, right? So it's my greatest possible value is 1. It's not the least, and I'll tell you why. Again, if you look closely here, right? If you look closely, it's a negative sign, right? So this is just going to decrease whatever that is left here, right? It's not going to add to what we have here. It's going to, subtract, right? So whatever this value will just subtract everything with it because there's a negative sign to it. If there was a positive sign, it would be, 2, 3, 4, it would increase. But as x increases, y will decrease because there's a negative sign here. You can take any value again. I don't mind. You can take 2, for example, right? Sorry, not 2. We already took 2 because we got 0 here. But you can even take, 10. Or I'd say take a perfect square. Take 18, right? When x is equal to 18, or sorry, can we take 18? Wait, that's it. No, we're gonna have to take. No, we can't take 18 because that's outside the domain. Let's take negative 6. Let's take negative 14. Right? When x is negative 14, we have 1 minus 3 times 2 minus negative 14. Right. So this negative cancel out, give us a positive. Right. So we have negative. So we have 16. 1 minus 3 times square root of 16. 1 minus 3 times 4. Just 12. 1 minus 12, which is negative 11. Right. So we have negative 11. So you can see that every time we increase the value of x, right? Or in this case, we decrease, right? As long as we go further, right? I say increase, but it's actually decreasing because we're actually just going further down the domain, right? That's what I should really be saying, right? We're getting a smaller and smaller value. So when I was saying x increases, I actually just mean going down the domain or taking further values away from the starting value, right? So you can see that the greatest value is going to be 1, right? When when we have x is equal to 2. So our range, right? Our range here becomes y is less than or equal to what, right? That is our range. Again, you see, so every time we experienced a different function, right? Sometimes, so I can make out the 4 cases right here. I can draw out the 4 cases right here. So I'll take a line, make a line right here, right? And I'll take a different color. So we have x and y, and then I don't know. So yeah, so or let me just do it like this only. So when we have x positive and y positive, right? So we're gonna have a graph like this, right? When we have x negative, y positive, we're gonna have a graph, like this. When we have x positive and y negative, we're gonna have a graph like this. So I could say like this is my axes. These are my axes, like this, right? Fourth is when both are negative, right? Both are negative. When x is negative and y is negative, I'm gonna have just a second. Let me redraw this axis. All right, so I'm gonna have something like this, and I'm gonna have something like this that goes. So what you can see here is different, ways my radical function will open, right? Based on whether my x's are negatives, positives, or whatever, right? Here, majority of my values are going to be negative. So I can look at, x is going to be mostly negative and y is going to be mostly negative as well. So you can expect, something like case number 4 here, right? My radical function will be something like this. Obviously, it won't start from the origin because my domain and range are different, right? So those things you also have to take in mind. But otherwise, like I said, look at the question, see what it's asking you. It's going to be a different case every single time, and therefore you can't go with this mentality, right? Okay, I'm gonna do this, I'm gonna do that, and so on and so forth. No, start from the domain. Look at what the domain is. Right now we just had like a linear function inside, but this could have been 2 minus x squared as well, right? 2 minus x squared, then what would you do? You're gonna have to break it up, right? You're gonna have to see where x is always, then you're gonna have to use the things that we learned in quadratic function, right? See, this is how the IB mixes different concepts together, right? They'll never ask you, just give you quadratic and then solve, find the roots or something like that. But they might instead put uh, 2 minus x squared, and now they're gonna ask you find the domain and find the range. So what you would have to do is you'd actually have to find the domain of this. Then you're gonna have to find for what values of this function it's gonna be greater than 0, right? Based on that, then you're gonna have, so the range of this function actually becomes the domain of this function, if you get what I mean, right? So this function has to be greater than 0 to satisfy this radical right here, right? To satisfy the square root. Then we have to look at this, right? So all of those matter. Now, what would you do if you had a square root inside a square root? So like square root of x minus square root of x, like this, right? So first you have to satisfy this condition. Then you're gonna have to satisfy this condition, right? So something like that. Those things can also be done to make it a little bit more tricky, as long as you stick with your general understanding of what a function is and how the function operates, right? And that is, just from the general understanding of this part right here, right? You just have to know what's happening where, and you'll be fine, right? No matter how tricky the question gets, you'll be fine. See, so far the IB doesn't really focus on radical functions just yet. They might just ask you domain and range for a few marks, and that's it, right? I don't think it's going to get too complicated, but something like this in paper 3 can come. They can overcomplicate things in paper 3 because it is paper 3 and they have the right to do so. So you have to be careful with that. So yeah, with this we finish up radical functions, and in the upcoming video we'll take a look at absolute value functions. So that's absolute value is a little complicated. It's going to be more than one video long, right? Maybe 2 if not 3, right? Depending on how I put up the course, right? So depending on how the IB has the course structured, and depending on how many videos I feel I need to explain the whole concept, I'll make it maybe 2, maybe 3. I'm not really sure. So after absolute value, we'll take a look at composite functions, even and odd functions, and stuff like that, right? We'll take a we'll review those functions again when we come to trig as well, because that's also important. But for now, we'll just work with non-trig functions. So yeah, that was all for today's video, and I'll see you in the next one. Bye bye.